Hi, we're moving right along in the course. We're in section 3.2 now. Now that we've gone through 3.1 and we've done that limit definition of derivative, they're starting to give us nice shortcuts, all these nice derivative rules. I just want to warn you that on the test, I will make you do a derivative the long way at least once. So I'll make you use that limit definition of derivative with the difference quotient as delta x approaches 0 and all that good stuff. So you want to memorize that difference quotient and that limit and you're going to want to be able to do a derivative that long way one time when you get to the exam. But now we have all these nice shortcuts. So I just want to show you a few problems from section 3.2. This is number 4. The key to number 4 is you can rewrite this function, right? I've got the 5th root of x. I can rewrite that as x to the 1/5. And then just use the power rule, right? Just to remind you, the power rule says if you've got some function f of x equals x to the n, all you have to do to find the derivative of f of x, f prime of x, is bring that exponent out front as a multiplier, so it's n times x to the, and then lower your exponent by 1, x to the n minus 1, right? So to do this derivative here, all I have to do is bring that power out front, 1/5, x to the, lower the exponent by 1, negative 4/5. It would be fine to just actually leave it that way. It's not very useful in that form. It's hard to evaluate functions. If I give you an x value, it'd be hard to evaluate it in this form. So it's nice to change it a little bit. You could change it, right? We've got a negative exponent. We could put that in the denominator, x to the 4/5. And you could even change that to 5 times the 5th root of x to the 4th if you wanted to, right? That'd be a good enough answer for our derivative right there, using our power rule to find the derivative of a function. Okay, now in number 10, we're going to do that same sort of thing, except we're going to use it a little bit. We want to find the slope of this function at a specific value, right? So we need the derivative to find the slope. So I need to take the derivative of this function. Well, again, this t here, it's in the denominator. Don't let this little guy here confuse you. That confuses a lot of people. That's just a comma. It's not a tick mark for a derivative or anything like that. It's just a comma at the end of the function to separate the function from the point. So just ignore that little mark right there. But what we're going to do is we're going to rewrite the function again to make it easier to take the derivative. So f of t could also be written as 2 minus 4/3 t to the negative 1, right? That negative 1, putting it in the denominator like that one. So we're going to go ahead and do our power rule here. If we take the derivative of that, remember the derivative of any constant term is 0. So that's just going to be 0. When I do this part, I'm going to do negative 1 times negative 4/3, right? I'm doing power rule. Multiply by negative 1, right? Multiply by n. Multiplying by negative 1 gives me positive 4/3 t, lower the exponent by 1. So negative 1 minus 1, negative 2. So there's my derivative. And again, I'm going to write it in a more useful form. Maybe I'd change it to 4/3t squared. So there's my derivative. And now what I want to do is evaluate that derivative at 3/4, right? So f prime of 3/4 is going to equal 4/3. And that quantity of 3/4 squared. And the rest of the problem is just evaluating that. So squaring the fraction gives me 9/16, excuse me. Multiply by 3, you get 27/16. And multiplying by the reciprocal, and you could change that to 4 times 16/27, which gives you 64/27, okay? So that would be the slope of this original function, f of t, evaluated when x is 3/4, right? So that's the slope of the function at that value. I just want to show you that your calculator can do this also. Just to remind you, there's a video about this in our Blackboard site, but just to show you, if I put this original function in, 2 minus 4 divided by 3, I'm going to use x instead of t, just for ease. So I'm going to graph that function. And to evaluate the derivative at any point along the graph, you can press second and calculate. Get into that calc menu there. And we're going to want number 6 because we want to evaluate the derivative there, dy dx. So number 6. And now I can plug in any x value I want, and it'll kick out the value of the derivative. So I'm going to put in 3/4 for my x value, right? Because that's what we're putting in here for t. And it gives me dy dx is equal to 2.37, blah, 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 blah. And then just to check that that's equal to this, right? That's just the decimal approximation of this fraction, 64/27, 2.37, etc., right? Then just to check that, you can quit and say, okay, what is 64 divided by 27? And you definitely get that same value, Okay, so that's just a way you can check on your calculator, make sure you're doing these things right. One more question from this section that people sometimes struggle with. I'm gonna kind of let the cat out of the bag. If you don't know what to do on this next test, take the derivative. So I was about to jump into this problem and just do the derivative without explaining why, but that's actually a pretty good strategy for this test. I mean, the test is all about derivatives, so if you take the derivative of a function, you're probably on the right track. But what they're asking us to do in this problem is determine the point where the graph of the function has horizontal tangent line, Well, horizontal tangent lines happen when the slope is 0, right? That's what I translate that into. If it's horizontal, the slope is going to be 0. All horizontal lines have a slope of 0. So if the slope has to be 0, what I'm looking for is when the derivative is equal to 0. Remember, the derivative is a function that kicks out the slope instead of kicking out the height. So I want to set the derivative equal to 0, and that will tell me the x values where this function has a horizontal tangent line. Okay, so first, taking the derivative of the function. I would again rewrite this one, 5x to the negative 2, right? Now do your power rule, y prime equals negative 2 times 5, negative 10, x, lower the exponent by 1, negative 3. And rewriting that, I'd put negative 10 over x to the third. Now remember, what we're trying to do is find out where the slope is 0, and since this function represents the slope, we can set that function equal to 0. And it turns out when you do that, this is actually impossible, right? These two can never be equal. There's no value you can plug in here for x to make this division equal 0. Just not going to happen. So this has no solution, which means there is no point on this function that has a slope of 0. There's no horizontal tangent line, no matter where you go on the graph of this function. So we would put, I think it says none if there isn't one. So I'd enter none as my answer. And just to show you that, again, calculators always help. So just to show you that on the calculator, if I graph that original function, y equals 5 divided by x squared, I graph that, looks something like this. And you've got asymptotes here. There's a vertical asymptote here, and there's a horizontal asymptote that runs at y equals 0, and that's kind of the key. This function is always decreasing this way, and it's always increasing, so there's nowhere where it flattens out. So there are no horizontal tangent lines. Well, I hope that helps for section 3.2 on your homework. Just as always, email me if you have any questions.